about those lists. So back to the homework assignment. So it says, all right, here's some demo code that you can use. For instance, the insert function here. Let me take another look at the insert function. The insert function right here takes a pointer to another node. So what I could potentially do is say root insert, right? And I could insert something like this, new node, and pass some value here, like 789, right? So there is a possibility to do something like this. Essentially create another node using the new operator dynamically, and then store the value there, and immediately insert this brand new node created at runtime by the new operator, insert it immediately into the list, right? So as a result, there will be a root node and dynamically allocated brand new node at runtime and insert it into the list. So this is what this particular example demonstrates. Then we can display all nodes by using our print list helper function. So something like this we can do immediately. Print list, right? And all it needs is basically give us the root, and from that root it will be able to drill down the entire list and print everything. Let's make sure we can compile this and try to run it. Right, so it prints something here. Let me modify this so that we're going to be using it today. So let's make some adjustments here so that it's all visible. Easier display. Right. So it basically the format that it prints is, it says, all right, there are two elements present in the list. There's 4, 5, 6, and there's 7, 8, 9. Right. So the outcome of us creating the root node, then inserting something else into the list, another node which we created by the new, results in creation of this list. That's fine. So that's an example of this. Interesting example here. Remove all dynamic nodes from the list. Let's picture this. Paint. Let's just illustrate what's going on. And by the way, let's do another change here. So let's do this a couple of times. 7, 8, 9, I don't know, 5, 5, 5, right? So if I save this and run it again, we get slightly longer list with now 3 elements. Now notice that 5, 5, 5 got inserted in front of 7, 8, 9 because we used the same node, root, to insert everything. So the root just says, insert in front of me, insert in front of me. Right? That's what it does. So first we inserted 7, 8, 9, then inserted 555, and it kind of pushed the 7, 8, 9 out. All right. Now back to the sample. It says remove dynamic nodes. But again, let's illustrate what's happening here. Oh, I don't know what this is. Let me just go straight to Paint. Okay. So here's the situation. First of all, we have our main, right? We have our main call. And as a result of that call, we get this stack frame where all local variables are created. What we did here so far is that we created the root. So the root is like in this space, somewhere here in this space, the root is created. Right? Then we said new twice. New, of course, allocates memory on the free store, asking free store to provide the memory for new object. So what happened was that the brand new so this contained data 4, 5, 6, right? 4, 5, 6 was stored in this node, allocated directly as root. Then we created 7, 8, 9. It was created somewhere on the free store, somewhere here, right? So this is 7, 8, 9. This new allocates data on the free store. It's not part of the local storage. So it's just a runtime request. Allocate memory, and let's create this particular object in that allocated memory and call its constructor and make sure that constructor executes and the data is stored there. So that's what happens. However, as soon as we create new, we immediately, as soon as the constructor finishes, we insert this pointer. New returns pointer to the new object, right? So the new returns this pointer to the brand new object. But what we do, we call insert on the original root object, and so physically this begins to point to this next node. So we formulate the list. So this is locally allocated object, and this is dynamically allocated object. Anything that gets allocated by new is dynamically allocated. Then we create yet another one called 555. So 555 is allocated allocated on a free store, and I kind of, just draw them anywhere I want. So this is 555. My scratch writing here is horrible. But what happens is that it gets inserted in front and then gets pointed there. So let me fix. Obviously, this pointer is reconfigured so that instead, as a result, this begins to point here, right? And this original root points to 555. And so we have this list in memory. So 2 dynamically allocated nodes and 1 root. So we make an assumption, if we make an assumption that the root is not dynamically allocated, but the rest of the elements are allocated dynamically, we could potentially take this example of this code and say we can remove all dynamic nodes from the list. So let's try this, right? Let's try this fragment and consider what it does and how it looks like. Now, I named my root node root. Here it says head, so I'm just going to rename. Control H and rename all heads with roots, right? And would be desirable to match the case and match a word boundary and just say replace all, right? So there's actually only one replacement was made. So the approach to this work is as follows. Let's create like a temporary pointer named iter for iteration, iterator pointer, which starts with pNext, right? In our case, we kept pointer to the next node, right? So in all of these guys here, this arrow and this arrow, this is pNext, right? pNext, pNext, internally, and this pNext, as we know, points to null, essentially marks the end of the list. So so we say let's start with the next node, and then we can say if this iterator that we got from the next pointer to the next node, if it's not null, right, so it's something real, then we can then mark it as obsolete, advance the iterator, just basically say now that we have this iterator, right, iterator, this little iterator pointer begins with pNext here, so iterator starts here. Then we create another pointer named obsolete, named obsolete, and basically we remember location of this node once again, and then say, iterator, why don't you move on to the next node? What happens is that this next node now gets assigned to the iterator. So our iterator now begins to point to whatever this p next is pointing to, right? So now on this particular line, what we just did, that we're no longer pointing here, we're pointing all the way down to this next node. And then we say, let's delete the obsolete, right? So we use this obsolete temporary pointer to say, let's delete this object. So this object goes out of scope. I can just kind of evaporate it like this, right? So it's gone as a result of delete. And we continue this loop. So we just say, okay, iterator, if it's still not null, and we're still not null, we're pointing to the next one, right? So again, the game begins. Obsolete now will be pointing to this again, because we say let obsolete point to whatever iterator points to. Make sure we advance the iterator yet to the next one. So as a result of this, our iterator next will be pointing to the whatever the next one is pointing to, which is null, right? So it will now be pointing to null, which is like 0, right? And then say delete obsolete. So delete this obsolete, and this one will be deleted as well. Let me just save this